Today, as we are all testing, we all are testers, of course, and software engineers and software quality engineers. You all, at some point in time, logically have a system under test. There's nothing strange about that, right? It's something many of us do in this room on a daily basis. You're testing and you're fully immersed in what you do at your work. And at some point in time, you start, of course, logically to make your tests, your test cases. And whether you use those in your test automation or for your manually test that you try to execute, it doesn't really matter in this example. But everything seems to be going well, but then the pressure mounts. The development team is taking, of course, a little bit more time than originally scheduled. But the deadline is still set for next week. Sounds a little bit familiar, right? I think it may be a little bit over-exaggerated a little bit, but suddenly everything is under pressure. We've all experienced it at some point in time. You try to run some tests then, and then it happens. No data. No database. The test data is unavailable. In short, in the results, some of the test data cannot be executed. But meanwhile, the business is asking for a delivery date. We need to move forward. We just can't wait. We need to go to production as quickly as we possibly can. At this moment in time, everyone in this room probably already knows what's going to happen. We are going to create our own test data. You get started and begin setting up some test data. And maybe you will use the fictitious names and customers that we all know, like Donald Duck and Jane Doe. And perhaps you also work for an insurance company, and so you need some of the data, like I showed you. And you need this test data to put it into your test automation, or you need to enter it manually into your system under test. So you end up doing it. And in the end of the day, it ends up eventually in your database and your application. Sounds great, right? But this is also where it gets a little bit interesting. Because that simple test data that you created, perhaps only those 4 columns, spreads under the service across multiple different tables. You might not have expected it, but those simple 4 columns appear in a customer table, in an order table, the product table, and even a payment table. What initially seemed simple quickly becomes complex. And so it is in reality. Because in reality, your system doesn't contain just 4 tables. It most probably will contain 500, 1500, or even sometimes 10,000 tables. How do you manage test data in this complex world? And then it makes it even more complex, because today we're not using just one system, but often we have multiple systems, different database technologies, various formats like XML, CSV, JSON, Parquet. And additionally, we also work in the clouds. We have SaaS applications, and we also deal with external partners as well. How do you manage your test data in such a complex world? Today, I want to talk to you about this important subject, test data. And by the end of my presentation, I want all of you to have a bit of an understanding on how to use test data effectively at various stages in your software development pipeline. I will explain this in a step-by-step way during the different stages in your pipeline. And of course, I understand in this presentation it might sound quite simple, but I also understand that it is in reality way more complex. Still, my goal for this presentation, in the end of the day, is that you have a better understanding on how the right test data can help you deliver even better software. But let me briefly introduce myself. My name is Maarten Urbach. And as you already might noticed, is that I am originally from the Netherlands, and I still live there. And I've been fortunate enough to work at DATPRO for over 15 years, where I have been involved in test data management throughout that time. I'm one of the co-founders and owners of DATPRO. And in those 15 years, I have had the opportunity to help many clients with their test data challenges. I must say, sometimes with wonderful successes, but also sometimes quite challenging, as things go. but every experience has given me some valuable insights over the last 50 years. And I hope to share some of that with you today, and I hope it will also help you move forward. In my free time, I'm also quite occupied because I'm the father of a big family. So in total I've got 5 kids, which keeps me busy, of course. But I also enjoy my children and I enjoy coaching them in their hockey sports. A brief introduction before I start with the real content. So excuse me, but a brief introduction of DATPROF. DATPROF is a software provider. And we are specialized in test data solutions. We offer a platform, and with that platform, with the different modules, we help our clients with anonymizing data, generating data, creating subsets of data, or virtualized databases. Our goal, our mission is simple. We love to solve complex test data challenges, so our clients, our customers can quickly and easily access the right test data. What makes us different? What makes us stand out? Well, I think we are approachable and we are mainly quickly ready to help. We love the ease of use, but we're also approachable therefore. And in the end of the day, we are focused and centered upon test data. We love the challenge of test data. If you'd like to know more about our test data platform, or how we operate or how we work, feel free to send me a message on LinkedIn or via email. And I'll be happy to tell you all about it. But for now, I will focus on the content of my presentation. So, for the content of my presentation, I think before I really continue with the different stages, let me briefly give you a moment to explain what kind of techniques I will explain during my presentation as well. So, I will use these different techniques and I will mention those in my presentation as well. I will mention synthetic test data first. Synthetic data. Synthetic data in my presentation means that we will generate data that didn't exist before, or we will use seedless to generate data. So we will be, either it will be about generating complete new tables with data inside of it, but it can also mean replacement of existing data. That's also a little bit a small difference with data masking, because data masking is primarily the obfuscation of data, anonymizing data, but it's also already existing data that's in your data source available. So we can replace data with the shuffle combination, for example, or blanking, but also using synthetic data generation to replace existing data. Whether synthetic data in my presentation is more about generating data from scratch which didn't exist before. Data subsetting is a technique that helps us and helps clients with extracting targeted sets of data out of a source and place it into a low environment. As a result, the data and the database is way smaller than original, and therefore it's also more manageable and easy to place in a test environment rather than using and loading full-size copies in these environments. Last technique that I will mention during my presentation is database virtualization. Database virtualization is a way that you can virtually make copies from a database. So instead of dragging around full-size copies to different lower environments, you can make virtual copies of these environments. We store the deltas, we make sure that we hold the differences, so you can also easily version data, but you can also clone snapshot data within seconds. So you can spin up environments, but you can also quickly return to an original state. So with that being said, let me briefly explain the software development pipeline that I will use during my presentation. I will start, of course, with the development phase. So we will start with the development of the software, and then we move forwards until the end of the day to regression testing. And in the meantime, we will discuss the integration testing, system testing, end-to-end testing, acceptance testing, and of course, production. Well, production is a pretty easy slide, I would say. That being said, you can arguably say and debate that we're missing some testing, like performance testing, load testing, security testing, maybe that's something for discussion later on as well. Where could you place it in your software development pipeline? Because it's somewhere, of course, in multiple stages already in your software development pipeline, if you ask me. So that said, this is always an interesting discussion, and that we can always do afterwards as well. But I will make my presentation according to this software development pipeline for now. So let's start with the development phase. Well, we left the ID development, the thing that we try to achieve, the thing that we try to build out of my presentation, but we will focus on the actual development phase. And during this phase, during unit testing, the primary focus is on writing code and ensuring that individual components of the system work as expected. These components are often very small pieces of functionality. And this is also exactly why we call it unit testing. We're testing the units that you developed. Unit testing therefore also logically takes place during development. And here comes always the fun discussion between the testers and developers. Who's responsible for unit testing? My humble opinion, I think in the end of the day it's the developer's responsibility. I understand that we have a role in it as well as software quality industry, but primarily the developers are in the end of the day responsible, I would say, for unit testing. In terms of test data, well, the needs during these tests are often still quite simple at this stage. The tests are so specific and isolated that you can easily get by with simple synthetic test data or mocked data. If you think back to my original example that I also used when I started this presentation, such a simple table could already support a unit test, especially if you're not touching many tables at once. If you don't touch those many tables at once, the need for complex and representative test data at this stage, I would say, is not really high. You simply need simple test data. This type of data can often be easily generated as well, also using like tools like the Gen AI or generative AI. You can easily also use these kinds of tools for generating this test data as well, I would say, because the need for representativeness is still relatively low. Then again, in unit testing, I would like to mention a few things that might come in handy as well when it comes down to test data and unit testing, because it's also important that test data is repeatable. And this means that each time the test is run, the same data should be available so you can run your test repeatedly and consistently. And this prevents test outcomes, and this prevents random test outcomes, of course, and ensures reliable results. And unit test also needs to be fast. And this is one of the reasons why simple, synthetic, or mock data is often the choice. Loading large datasets, for example, can really slow down the speed of the unit test, whereas these tests are intended to give developers and software quality engineers quick feedback. Database virtualization in combination with the synthetic data may come in handy, so you can easily move up and down the different versions of your test data as well. Finally, although test data is simple at this stage, it still needs to be representative enough to catch some errors. So simple test data can have a basic structure, but don't forget to consider scenarios where code just might fail. A bit of variation in the test data can help bring these hidden bugs to light. In the next step, we will start discussing the integration phase, the integration testing. So we finished up the development phase. In the next step, things also get already a little bit more interesting. In integration testing, in integration phase, we connect the various components that were developed during the development phase. The goal during integration testing, of course, is to ensure that these parts can communicate and work together as we intended. We combine the system modules and test interactions between these modules. And in this phase, it is crucial that the test data can accurately simulate these interactions. So the test data needs to be representative on how the different components would interact in real system. In this example, let's say in the insurance industry, you might want to test how a patient and a healthcare provider are linked in the system. Here, the test data should ensure that these interactions are simulated as realistic as possible. In cases, you can still work well with synthetic test data over here. Because synthetic test data can, especially also in integration testing, can easily simulate these basic interactions between the modules. It's quick to generate and can be easily tailored to your specific test cases. So the data in this particular stage don't often need to be fully realistic as well. But as long as this covers the necessary interactions between the different parts. It can already also in this stage, the complexity can start to increase. Data consistency can become more and more important in this stage, especially dependent on the different industry. If you have a high need and high history then and complex systems, the integration test and the need for more realistic data might become important. You need to be able to ensure that the data is consistent across the multiple modules that you try to test. For example, if you would add a customer in the customer table, that same customer should then be also visible in the other tables or in the customer history table. Without this consistency, your integration test can produce, of course, unreliable results. So depending on the industry, it may also be necessary to work with more realistic test data. For example, in the insurance industry, it can be quite complex quite quickly. This is especially true if you're testing a system that has many dependency and historical data. The more complex the system, the more important it becomes to use the right data structure and characteristics of production data. These scenarios can easily be simulated with subsets, but also with some synthetic data as well. But you should consider making specific cases in your production environment as well, so you catch bugs early, shifting left. In systems with many transactions or historical data, it might already be wise to think about using a subset of production, because this provides a good balance between realism and manageable complexity. It is also interesting, of course, in these stages to consider the edge cases during your integration test, because edge cases such as incomplete or outdated data can cause integrations to fail. Testing these edge cases ensures that your system continues to function correctly, even in exceptional situations. So therefore, the test data should also simulate these specific scenarios. So you need to design synthetic data that is specifically designed for test error prone situations. The final thing that I would like to mention is if you're working with a CI/CD pipeline, it's wise to automate integration tests as much as you possibly can. This also means automating the creation and management of test data. With automatic data set provisioning, you ensure that the correct data sets are available when needed, without any manual intervention. And this speeds up the testing process and ensures that the right data is ready for you to use in your tests. In the next phase, we will be discussing the system testing. We will discuss testing the entire system. Therefore, the test data requirements also change. We need to look at more realistic data to see if a system continues to function well under production conditions. In system testing, we go beyond validating, of course, the individual components of integration testing. Here we test the entire system in a simulated test environment, if you have one, to see if all the parts that we created, all the components work together as they should under realistic conditions. The goal is to validate whether the system behaves as expected. Therefore, the question already a little bit maybe rises. should you perform system tests with a full-size copy of a production database? Or can you just as well work with a subset of a production data? I think in most cases it is more efficient to work with a subset. Why? Because you want to test the functions of the systems without having to work with a full production dataset of tens of gigabytes or tens of terabytes. What you want is you need a specific targeted set of test data that is representative of production, but smaller and easier to manage, but also figures out the way that a system works. Subsets are therefore the ideal situation. They offer the right balance between representativeness of your production data and manageability. You can therefore, due to the size, can also move back and forth easily, and small tests run really fast through this system. So instead of struggling with the complexity and time-consuming processes that are involved with managing full-size copies of production databases. This not only makes system testing more efficient, but also more manageable. So in this phase and during these tests, it's crucial to ensure consistency and integrity of your test data. And subsets, especially in a system, helps you to simulate key data flows without having to work with the full dataset. And of course, also if you're working with a CI/CD pipeline, you also have to think about automating the provisioning of test data to your lower environment. And in this way, you ensure that the correct data sets are immediately available when tests are executed. This saves the time and reduces the chance of error. But we need to make a little bit a step deeper into system testing, because when we are using full-size copies of production in system testing, which still might be the case, but I would strongly recommend using subsets, we are still using production data, because a copy of production can be used or a subset, but a subset from a production database still contains production data. So whether you use full copies or subsets, you also need to consider compliance. What about compliance with regulations such as the ISO 27001 or GDPR or other privacy regulations? You must ensure that the test data complies with all the laws and regulations, especially when it comes to privacy sensitive information. And in the earlier stages in integration and in unit testing, it might be good enough to work with synthetic data. In integration testing, that's a little bit debatable already, and therefore also masking data in these stages might be critical to do as well. In some cases, you just cannot avoid using with anonymized production data. So this means you need to think about a process of masking, or that's also known as sanitizing or obfuscating test data. The goal with masking is to ensure that you are full compliant with GDPR or other privacy regulations, while still being able to perform realistic tests with production data. So, with that being said, we're also moving forwards to the end-to-end testing or chain testing phase, or as we call it. I like to call it end-to-end testing. And during this phase, we validate the entire end-to-end, the entire chain of system. From a user interface through the API and databases to external systems that our systems communicate with. The goal is to test whether the entire system worked as expected and how well all the parts work together. In end-to-end testing, it is so important to work with production-like data to simulate real business processes as accurately as possible. So instead of working with subset, it can also be handy and useful during this testing to use database virtualization or a copy of production databases. With database virtualization, you can work with full copies of production data without the downside of large storage requirements or long waiting times for making these copies of production databases. Instead of using physical copies, you will be using virtual copies, which use snapshots and deltas or clones. This means that the only changes compared to the original dataset are stored, allowing you to test quickly and efficiently. With virtual databases, you can perform realistic performance and load tests as well, without waiting for large physical production copies. And this ensures that your system is tested under realistic conditions, with a minimal impact on your storage infrastructure. Another advantage is also that you can quickly switch between the different environments and test cases, giving you more flexibility when performing complex tests. But also in this stage, compliance remains important, because even though you might be working with virtual copies or with a full-size copy of production databases in these environments, you still need to ensure that anonymization practices of sensitive data are in place so you can comply with GDPR and other regulations. In end-to-end testing, it's also focused on how well the integration work with external systems as well. So if certain systems or APIs are not yet available, you can also think about using service virtualization. With service virtualization, you can simulate these external systems and you can still carry out the full end-to-end test without the dependency and availability of those systems. Finally, in end-to-end testing, it's really important that you have a masking and subsetting and test data consistently over multiple systems. So when you start masking, you need also a system that if you mask system A, that system B is consistently masked. And the same holds true for subsetting, and the same holds true for database virtualization as well. In this stage, you want to test everything. And it might be interesting to virtualize the services and APIs on the edges of your system too. And then I will be moving forward to the acceptance phase. In this phase, the test environment, I would say, would not always have the need to be as large, as complex as a full-size copy. Maybe this is a little bit unexpected in this stage, but I would try to aim to keep this environment as small and manageable as possible, without sacrificing the quality of the test. And also in this stage, a technology that I think is also interesting to use is service virtualization in combination with test data management and test automation. We don't offer service virtualization or test automation tools, but we do support our customers with test data that can be combined in these different technologies. And you can then conduct highly efficient acceptance tests. So think about this. This is something I think is pretty interesting. If you have a system under test, with a database underneath, possibly a subset of production or a virtualized copy maybe, with service virtualization, you can virtually simulate the surrounding services and APIs. And this allows you to test without the need of a full large environment that simulates the full environment and an acceptance test. You can create a smaller, more efficient test environment that you can use especially for users, for the user acceptance test, giving users the ability to work with it. The alternative, of course, is to use a full copy of production database. But this is often also the case I see in user acceptance testing. But in the end users are involved in this test, and whether the system on the test works, they need to test, of course, that it's technically consistent and that it meets the functional requirements and the business objective. That's the reason for the user acceptance test. And it is essential to work with realistic, but you can also work with anonymized data. And I would say to test it, you don't need a full-size copy. Also not for training, of course. And this allows you to run these tests faster and more efficiently with fewer risks and lower costs. In short, the acceptance phase, the acceptance testing can also be about a smaller, manageable environment that can run the necessary tests without the unnecessary overhead. The last point that I will try to discuss, of course, is regression testing. Because after we've done acceptance testing, we move forward to production. We go to production, and that's all fine, and now everything is settled. But regression testing is the last bit that I would like to discuss over here. And in regression testing, and I'm still quite enthusiastic about this picture, I have a nice analogy, the Newton cradle balance. I think it's an interesting picture, but because this illustrates exactly what we want to achieve with regression testing. You set something in motion that's already in motion. In other words, you have a system that's already in production and it needs to keep working even after you've made changes to it. Regression testing aims to check whether bugs have been fixed and whether new features work correctly without affecting the existing functionalities. We want to make sure that everything in the system continues to function as it should, despite new additions or changes that you've made. And this testing, it is super important to think about how you handle your test data efficiently. The data must be able to directly simulate a realistic production environment. And that's why subsetting plays a crucial role, I would say, in regression testing. With subsets of your production data, you can exactly catch the parts of the system that have been modified without you need the full-size copy. And additionally, it's smart to use a combination of synthetic data and subset data, because the new parts, the new functionality, the data that is required can be added with synthetic data to these specific scenarios. So by combining the synthetic data with subsets of production, you can quickly and efficiently get started with your tests. Then, since regression tests are often repeated after each update, automation is also really critical. So automating these steps can be really interesting. With automated test scripts, you can quickly and consistently check if the system still functions correctly after each change. This ensures that you don't have to manually run the same test over and over again, saving tremendous amount of time and resources. In these stages, you also have to think about, of course, the coverage. It's important that the test data and the regression tests focus on the critical functions of the system. So by testing the most high-risk parts of a system, you can ensure that the essential functions are not affected by change. And that's really important, especially if you want to make sure that the tests are covered properly. A little bit the same like this, I also think it's important to understand that not every part of your system carries the same amount of risk. So instead of testing everything, you can also follow a little bit the risk-based approach and prioritize the parts that are most vulnerable to errors or that have the greatest impact on the system and your organization. This way, you can focus on the critical functions where the most risk lies. Last, what's also I think pretty critical during regression testing and also with test data is that you have to figure out a rollback strategy. What if a regression test detects issues in production? It's important to have a rollback strategy so you can easily restore the system to a previous stable version. This is especially useful when regression tests uncover unexpected errors that needs to be addressed immediately. In short, regression testing is there to ensure that the system keeps running smoothly, even after updates or bugs. Or bug fixes, of course, more. When the right test data, with the right test data, in my perspective, a combination of subset and synthetic data, you can respond quickly and prevent these changes from causing unexpected problems when going to production. So, today, in short, we discussed the growing importance and the growing role of test data in every phase of your development pipeline. And in a little bit of a conclusion, as your system grows in your pipeline, the system becomes more complex and the requirements for your test data might also be growing. In the early stages, such as during unit testing and development, the test data is often still relatively simple. Here, the use of synthetic or mock data can be sufficient enough to execute tests because they are rather limited and there are isolated units or components. The complexity of test data is low, as is the need for accurate production-like data. But as you move further along the pipeline, such in integration testing a little bit already, but especially in system testing, the complexity increases. The systems become larger and the interaction between components becomes more important. In these stages, during these tests, the need for realistic production-like data becomes much greater. You then not only need synthetic data, but you can also think about subsets of production or even virtualized copies to ensure that these tests are representative of what happens in a production environment. In even the later stages, such as end-to-end testing or acceptance testing, you maybe want to perform near complete production simulations. This might also be interesting for your load and performance testing. You need to be able to test in an environment that is almost identical to production, but without the risk of real non-anonymized data. This is also where compliance becomes more and more critical in the later stages. You must ensure that your test data always complies with GDPR and that sensitive data is well protected. Thus, the demand for test data grows as you move further along in your pipeline. In early development you can still work with simple data, but in later stages you need increasingly realistic data. It is important to realize this so that you can adjust your test strategies and grow alongside the complexity of your systems. And this brings me to the core of what I would love to say. You need, in the end of the day, a scalable approach to test data. In early stages, synthetic data is sufficient, but later you will need more complex. You need subset and virtualization to make your test environments representative. And of course, compliance should never be overlooked. And then with that being said, I want to thank you all for your time, and I hope I gave you a lot of information. And the thing in the end of the day is that the test data is not just a tool, but it's a crucial factor in delivering high quality software. I discussed a little bit the role of test data in the different pipelines throughout the development of the different pipelines. But in the end of the day, the most important thing for everybody is that it starts with a strategy. I think it is essential to have a clear test data strategy that fits your software development methodology, whether it is in agile, waterfall, or maybe even a hybrid approach. In my presentation during this day, I used a fairly linear waterfall approach to make steps clear, but the techniques and the strategies we discussed are just as relevant in an agile environment. So whether you work in a short iteration or follow a long-term plan, a well throughout test data strategy ensures you're always prepared for the next step. And with that being said, I really hope that I give you all the necessary insight and tools to use the test data efficiently and effectively. I think I have a small few minutes left for some questions, so if anyone has any questions and want to discuss something, feel free to ask. Are there any questions?